Hi, this is Tanner from electronics123.com, and I am here in the Arduino compiler because today we are going to talk about the basic concepts of programming in the C language, and more specifically for programming the Arduino. So let's get started. We have a lot to cover. I've quickly written here this basic document which you'll be able to download from our website, which kind of outlines a lot of the basic syntax and the functions of the C language. The first thing here you'll notice is just a couple of comments that basically tell us a few important things. One of the big things that it would cause most people problems in programs is not putting a semicolon at the end of each line. That's one thing that's very important in C language is the semicolon. But you can read through those. I want to get more onto the more important things. The first thing is every Arduino program needs a setup method and a loop method. The setup method gets run once, and any code that you put in there is meant to set up your Arduino for the program that's about to be run. So if you have some constant integers you want to declare, or you want to set up your pin modes for outputs or inputs, it's usually a good idea to put that in the setup method. And in order for the Arduino to work, you must have a setup method. You also have to have a loop method, and the loop method basically runs repeatedly the entire time your program is running. So, and it basically will run whatever code, however long the code in the loop takes to run, and then it'll go and start at the beginning. So if your code only takes 5 microseconds to run, then it'll basically be running this every 5 microseconds. One important thing, basically in all programming, the point is basically just to manipulate numbers in intelligent ways to accomplish what your ultimate goal is. So an important thing that we have to be able to do to write programs is declare variables, numbers that can change. The most common one is an integer. And to declare one here, you can see I have int, and I called it my int, and I give it the value of 0. And then, of course, semicolon to end the line. And there's a couple different ways you can do that. You can also put here my int and my other int. They can be separated by columns if they both have the same value. And they can be given any value. They don't have to just be given 0. In order to work with these numbers, you have to be able to operate with them mathematically. There are 5 basic operators. There's addition, subtraction, multiplication, and division, and they're all shown here. Most of them are pretty straightforward. The 5th one is basically for returning a remainder. If you divide 2 numbers that don't divide evenly, using the percent symbol will return you that remainder. So, like if you want to check to see if a number is even, you could write this, get a remainder, and if you divide like by 2, if you do get a remainder, then the number's not 0, or is not even. It's an odd number. Probably the single most important thing to a program as far as being able to create functionality is the ability to create comparisons and controlling the comparisons. So comparisons and control structure. The comparison operators, there's 4 basic ones. Double equal sign, which is just checking to see if something is equal to something else. An exclamation equal sign, which checks to see if something is not equal to something else. And then the greater than or less than signs, which are pretty self-explanatory. In order to use these, you need to set up conditional statements, and that's where control structure comes in. 2 basic conditional statements are the if and the for statement. Now what an if does is it basically checks to see if the condition is true, and the condition is inside these parentheses. So you say if, open parentheses, your condition, in this case it's my int, does not equal my other int. And then close parentheses, you begin curly brackets, and then of course end curly brackets, and any code that is inside the 2 curly brackets will be run if the condition is true. In addition to that, you could also say if that condition is not true, you can use an else statement directly after the if with new curly brackets, which will basically run in the event that this isn't true. You can also put more than one condition by saying else if, and then typing a second condition in parentheses. The other conditional statement is the for statement, and for statements are usually used to run a certain block of code more than once, but for only a specific number of times, and they can be used with any integer. You see here we declare a new integer called I. We set it equal to 0, and then we check to see if I is less than 15, and then I plus plus basically means we increment I, so it's I plus 1 every time. And so what this basically does is any code that's in between these two curly brackets will be run 15 times, and then that will make this false, and it'll quit running this code. In order to make your Arduino actually function with the real world and talk to other devices and possibly light up LEDs or talk to other microcontrollers, you need to be able to control its outputs. The Arduino has the ability to do both analog and digital outputs, and setup for that's pretty simple. The first thing you need to do for both analog and digital is set up a pin mode. To do that, you type pin mode, the pin number. Let's say we want to use pin 13. You would type 13 here, or you could put an integer here that represents 13. And the pin mode, which is either going to be input or output, and that must be fully capitalized. So input, output. The next thing then, you either are going to write information to that pin or you're going to read information out of that pin. To write information to that pin, you set digital write, open parentheses, the pin number again, so like pin 13, and then the value. For digital, that'll either be a 0 or a 1, or you could also use high or low. Again, that would be all capital if you typed high or low. And then digital read, you would plug that into an integer. So we create a new integer, we digital read to it, and we give that the pin number, and that'll either read out a 1 or a 0. Now that's a little different with analog then. Analog, again, you're going to set up the pin mode the same. You'll say pin mode, and then the type, and so on. But then analog write, you'll be writing a value from 0 to 256, and that will basically be an intensity value of the output voltage. And again, you can read that back in and get the same kind of value, 0 to 256. So this is kind of basically what you would be using to write any of the Arduino programs. And if you start looking through other pieces of code, I would check out arduino.cc for more examples. You will probably start making sense of basically what the code is saying, and get a general idea of how you can edit it and change it to do what you want it to do. So thanks for watching, and tune in again next time.